Well, good morning, good afternoon, or good evening. This is Mrs. Robinson. I hope you guys are really excited to start our videos for finishing up college algebra. Um, we are going to be looking at matrices and their operations today. Just kind of as a quick review, we have our order. And if we recall, our order is our number of rows by the number of columns. And if we have forgotten, that could be in our RC cola, as in our pop. And if we remember, rows go left and right, columns go up and down. So if we wanted to find the order of matrix A, our order of matrix A would be equal to 3 rows, so 3 by, and then 2 columns. So it is a 3 by 2. If we are going to now look at matrix B, that has an order of 1 row by 1, 2, 3 columns. So it is considered a 1 by 3. And then last but definitely not least, we have our matrix C. And matrix C has 2 rows and 1, 2, 3 columns. Next, if we recall, all of our matrices have an address, and that address is the location of a number somewhere in that matrix. So for example, it says, what is the value of C sub 1, 3? What this is asking for, we need to go to matrix C, and what is in row 1, and what is in column 3. So that happens to be row 1, column 3 has a value of 5. What if we wanted to look at A sub 21? So that is saying row 2, column 1. So A sub 21, row 2, column row 2, column 1 has a value of 6. So that is kind of a quick review of what we had done prior to spring break. If we recall, there are going to be some special type of matrices. And our first special type happens to be a square matrix. And a square matrix has the same number of rows and columns. So for example, that would be a 2 by 2, a 3 by 3, or like a 4 by 4. So the dimensions ultimately just make a square. So that could be like 1, 2, 3, 4. So this would be a 2 by 2. We also have what is called a row matrix. And a row matrix just has a single row. So that would be something like 4, 8, 10. So this is 1 by 3. And I bet you can probably guess what a column matrix is at this time. And oh, look, I have a misspelled word. There is a huge shock that I forgot the N. So a column matrix has a single column. Okay? And so therefore, that could be something like 1, 2, 3 going vertically. So this would be a 3 by 1. And being able to tell the order of our matrices happens to be the absolute most important thing that we can do, because that leads us into our operations of matrices. The first operation that we're going to look at is adding and subtracting. Unfortunately, when I say operations, we're not going to be able to, to be at the doctor's office in surgery or anything. Just happen to be adding and subtracting our wonderful, awesome matrices. So, looking here, in order for us to be able to add or subtract two matrices, they must absolutely have the same dimension. And all that means is now if they have the same dimension, same size, we are going to add or subtract our corresponding entries. So for example, if I have matrix X minus matrix Z, scooch this up. There we go. So matrix X minus matrix Z. Matrix X happens to be 4, 7, 2, 5, 1, -1, minus matrix Z is 2, -2, 3, 1, 0, and 4. And in order for us to subtract those, we are just going to subtract their corresponding entries. So for example, we're going to go 4 minus 2. 4 minus 2, as we know, is 2. Finishing off our first row, we are going to go 7 minus -2, and that happens to be 9. And then finally 2 minus 3, which is going to give us -1. And then we're going to go ahead and do our very last row. 5 minus 1 is 4. 1 minus 0 is 1. -1 minus 4 is -5. We could also, if you recall, put our matrices in our calculators. And in order for us to do that, we need to use our alpha, zoom function. So if I wanted to go ahead and do that in our calculator, we're going to go alpha, zoom, maybe I should turn the calculator on first, alpha, zoom, and then we need to figure out the size. If we recall, the size of our matrix here is a 2 by 3, and this one is also a 2 by 3. So therefore it has 2 rows and 3 columns. And then we're going to go ahead and fill in our matrix. So 4, 7, 2, 5, 1, and then last but not least, -1. Double check, triple check that you did enter that in correctly. And from that, we are going to subtract our second matrix, and that would also give us alpha, zoom, and that is also a 2 by 3. And then that is 2, -2, 3, 1, 0, and 4. Once again, check, triple check, double check that you put that in correctly, and then just press enter, and voila! It happens amazingly to give us the exact same answer we had before. With adding and subtracting matrices, sometimes it's actually just faster to do it by hand instead of actually putting it in your calculator. So let's go ahead and look at the next problem. And it says we want to add matrix X plus matrix Y. So matrix X, that happens to be 4, 7, 2. 5, 1, negative 1. And we want to add that to matrix Y, 1, 4, negative 2, and 3. If we wanted to go ahead and try to add those together, notice this is a 2 by 3 and this is a 2 by 2. What happens with this is we cannot add them together. Unfortunately, since they are not the same size, we cannot add them together. If we wanted to go ahead and try that in our calculators to double check, remember we can go alpha zoom. The first one happens to be a 2 by 3. And then that is 4, 7, 2, 5, 1, negative 1. And we wanted to add that to alpha zoom. And remember, this one is a 2 by 2. And then that happens to be 1, 4, negative 2, and 3. And unfortunately, look what happens. We get an error message, and right there is the reason why dimensions mismatch. And it would say error, go to, and we can press 1. And our answer, unfortunately, is an error, not the same size. So we cannot add these together, not the same size. All right, so far so good, ladies and gentlemen. The next thing we're going to look at for our matrices and their operations is a multiplying by a scalar. A scalar is simply a number which is multiplied to each entry in the matrix. So for example, if this says 3R, so we have a bunch of matrices right here, and we want to go 3R, that is simply the 3 goes on the outside. Matrix R is 1, 4, negative 2, 3, 0, and 4. And notice this is right next to that single row right there, that second row. When we were doing our row operations before spring break, that meant we only multiplied or only did that, whatever that operation was, to that row. Now, since this is a scalar, that it now gets multiplied to everything. So this becomes 3 times 1, which is 3. 3 times 4, 12. 3 times negative 2, which is negative 6. 3 times 3 is 9. 3 times 0 is 0. And 3 times 4 is 12. You could also decide to put that in your calculator. However, as you have just seen, it is probably faster just to do that scalar multiplication on your own. So let's look at the second one, and notice it does happen to say if possible. So I am going to guess we are going to be good problem solvers right now and guess, hey, Mrs. Robinson probably has a problem on here that we are not going to be able to do. So you probably know me all too well at this point. But if this is saying we're going to go 2 times matrix P, which is 3, negative 2, 1, 0, 2, negative 1. And from that, we're going to subtract matrix Q, which is 4, 7, 2, 5, 1, and negative 1. before we even begin, what should we probably think to check for, since we are going to have to do some subtraction? So think for just a second before we subtract, what do we actually do? You guys are absolutely right. We have to see, do they have the same size, dimension, order? All of those words mean the same thing. So this one is a 1, 2, 3 by 1, 2. From that, we're wanting to subtract a 2 by 3. And notice this one cannot subtract, not the same order. I know that makes us really upset at that point, that we cannot finish that problem that we spent so much time writing down. Okay. And our last little bit of things that we get to do. It says solving equations using matrices. Or I should say solving equations which actually use matrices. So looking at this, and this is kind of one of those problems that tends to kind of confuse people when we run into it on a test. It says 2x plus b equals 3a. And it says solve for matrix X given that A is equal to this matrix and B is equal to the next matrix. So one of the things we have to understand, that all of these right here, the X, the B, and the A, that these are matrices. So the X, the B, and the A are actually matrices. So ultimately what we're going to do is solve this, what is called a literal equation for X. So first thing, solve the equation. Okay, so that is telling us, hey, we're going to look for matrix X. So we're going to have 2x plus b equals 3a. We are going to subtract matrix B to both sides. So 2x equals 3 times matrix A minus matrix B. Okay. At this point, to solve for x, our gut instinct is to divide everything by 2. Which is typically, normally 100% correct. However, we have a slight problem that we cannot, and this is really important, divide matrices. For some reason, that is an illegal operation. Cannot divide matrices. We can add them, we can subtract them, we can multiply them by scalars, and as we're going to find out in our next lesson is, hey, we can actually multiply them, but we cannot divide. So instead of dividing by 2, since all of these are matrices, we know that x is equal to 1/2 times 3 times matrix A minus matrix B. So x is actually equal to 3/2 times matrix A minus 1/2 times matrix B. And so now from here, we're going to go ahead and use those lovely little matrices that we have. So we know x is equal to 3/2 times matrix A, so 0, 1, 5, 2, minus 1/2, and then -1, 2, 3, 7. Now, you can go ahead by hand and distribute your scalar if you would like to each of your entries. However, I know all of us love to do or deal with fractions. So one of the things we can do is go to our lovely little calculator and go ahead and put them in. So we have our scalar 3/2, and then we're going to multiply that by matrix A. So we have our alpha zoom, and if we recall, this is a 2 by 2. And so then that happens to be 0, 1, 5, 2. And then from that, we're going to subtract 1/2. So 1 divided by 2, there's our scalar. And then our matrix B, which would be alpha zoom, also a lovely little 2 by 2. And so that would be -1, 2, 3, and 7. And we're going to press enter. And once again, does Mrs. Robinson like fractions? I am going to guess you're thinking, no, she doesn't. So remember, with our calculators, we can go ahead and hit math, enter, enter, and voila, turns everything into our fractions. So our matrix X is 1/2, 1/2, 6, and -1/2. Yay! Okay. So far, so good. Thank you for, keeping up with me. I know this is, I promise, the longest lesson that we have left because there's just so many little things left with it. And then our very last thing, what happens if we have two matrices set equal to one another? Because notice the directions simply say solve for the variable. So in this particular case, we have our two matrices that are set equal to each other. That means their corresponding entries are equal. So if two matrices are equal, their corresponding entries are equal. So that means, notice here that we have, that would mean 0 amazingly is equal to 0. Big shock. That also then tells us